Hello folks, welcome to my channel. Today we are solving another interesting thermodynamics related problem. The problem statement is air flows adiabatically through a horizontal duct and at a station number 1 the static pressure P1 is 150 kPa and the static temperature T1 is 200 degrees Celsius. Therefore, we need to convert it into Kelvins. So we need to add it by 273, and the velocity C1 is equal to 100 meter per second. At a station further downstream, the static pressure P2 is equal to 50 kPa and the static temperature T2 is equal to 150 degrees Celsius. Now we are asked to determine the velocity C2 and the change in entropy per unit mass of air. So we are asked to calculate the value of C2 and the change in entropy per unit mass of air, which is H2 minus S1. Now, according to the problem statement, the given flow is adiabatic, meaning that stagnation temperature at station 1, which is represented by T01, is equal to the stagnation temperature at station 2, which is represented by T02. Now, T01 can be written as T1 plus V1 square over 2Cp, where V1 is the velocity at station 1 and Cp is equal to 104.5 joule kg times Kelvin for air. Now we know the values of T1, V1 and Cp. Therefore, let's substitute the values of T1, V1 and Cp into this equation in order to first calculate the value of stagnation temperature at station 1. Now T1 is equal to 200 plus 273 plus V1, where V1 is equal to 100 meter per second and Cp is 104.5. So T01 is equal to 477.9776 Kelvin. Alright. Now T02 can be written as T1 plus T2 plus V2 square over 2Cp. Now, since the flow is adiabatic, T01 is equal to T02, and which is equal to 477.9776 Kelvin. So let's substitute the value of T02 into this equation and the value of T2 and Cp in order to calculate the value of V2. So T02 is equal to 477.9776. T2, according to the problem statement, T2 is 150 plus 273 plus V2 square. We are currently finding the value of V2 over 2 times Cp, which is 104.5. So V2 is equal to V2 is equal to 332.34018 meter per second. Alright folks, now let's determine the change in entropy. Now change in entropy from station 1 to station 2 is equal to H2 minus S1, and which can also be written as Cp ln T2 over T1 minus R ln P2 over P1. Now we know the values of Cp, T2, T1, R, P2 and P1. So let's substitute all known values into this equation in order to calculate the change in entropy. T1 is equal to 150 plus 273 minus R, which is equal to 287 for air, ln is equal to P2 or the value of P2 is 50 kPa and the value of P1 is 150 kPa, right? Alright, yes, P1 is equal to 150 kPa. Now this then equal to 427.5276907 joule per kilogram per Kelvin. Alright folks, this is the answer. Thanks for watching the video, and we will solve another interesting problem in next video.